Hello again, my friends, and welcome to the second part of the ninth video, into which, my friends, we are going to proceed answering the ninth question of the 2024 British Pearson Edexcel International IGCSE syllabuses past paper. Today's past paper, my friend, is going to be about chemistry, as we have talked in the previous 8 classes. And now, my friends, in the previous class, we have talked about the ionic compounds. First of all, we talked about two types of ions, and we said that ions are chemical particles that are charged, and we said that we have two types of ions in terms of charge, and we said that we have negative ions like those, and we call them anions, and we have positive charges like those, and we call them cations. And then we said that we can classify cations and anions into two classes also. We have something called monoatomic ions, and we said that monoatomic ions are ions that are made up of one atom, like this. This is, and this, those are monoatomic ions. So this is an anion. This is chloride, an anion monoatomic ion, and this is sodium, which is a cation, a monoatomic ion. And then we talked about polyatomic ions, and we said that a monoatomic ion is an ion that is made up of more than one atom, two or more, like this one, SO4, and like NH4. Also, this is a cation, polyatomic ion, and this is an anion, polyatomic ion. So, my friends, we talked about how to make a chemical compound, and we said that to make a chemical compound, we need, my friends, to take the positive ion, left negative ion, right? And we talked about exceptions like this one, acetate and formate. And then we said that we look at the numbers. If the numbers are equal in terms of absolute value, we ignore both numbers and charges, so that we combine the positive ions and negative ions without the numbers. And we said here we have 1, 1, and we didn't write any numbers here. We have 2 and 2 also. We ignored the numbers. We didn't use them. Here we have a 3 and a 3. We combined them without looking at the charges or the numbers. And we said that if the numbers are different, not equal, the first step is to ignore the signs or the charges. The second one is to exchange the numbers. Exchanging the numbers is very important in here, my friends. To exchange the numbers here, my friends, in the second rule here, we exchange the numbers. Of course, we ignore the signs. We have Na plus 1, and we have oxygen minus 2. We exchange them in Na2O1. So when there is number 1 here, we don't need to write anything. Here we have the opposite. We have calcium plus 2 and chloride minus 1. Then here we have number 1, and we don't write it, and we have number 2 here. And the last point here for chemical roots, or we call them polyatomic ions, like SO4, like CO3, like SO4, we said that we deal with them like they are all here, like one atom only. So when we need more than one of them, like this, we need to put them into parentheses, so that we tell that all atoms here inside the parentheses, they are multiplied with the same number, so that the whole root or the whole ion is multiplied with the same number. And today, my friends, we are going to proceed answering the second part of the question, which is give the name of the compound with the formula ZnSO4. In here, my friends, in this case, I can answer the question easily, and I said zinc sulfate. But I would like to give you a quick and brief revision of the nomenclature of ionic compounds so that you understand how I named this one and you can understand how to name the others. So, my friends, let's go through the question. How to name ionic compounds. Now, naming ionic compounds is not difficult, but it needs a little bit concentration and some willness, so that the students will understand how to name them. So in here, my friends, we have two major cases, A and B. How to name the positive ions and how to name the negative ions. Let's start with the positive ions, my friends. How to name the positive ions? Generally, positive ions, my friends, are metals. In our book, of course. The only non-metallic positive ion you are going to see is NHO4 plus, which is called ammonium. This is the only one you will see, but the others are metals. So how to name them? Naming the positive ions is very easy. Use the same name of the metal. For example, we have here sodium. This is sodium atom, which is neutral. This is not an ion here, which is neutral. So the free sodium is called sodium. And when the sodium is chemically bounded with the other, let's say, negative ions like oxide, like chloride here, like sulfate here, whether these negative ions are monoatomic or polyatomic, the name doesn't change. It is always sodium. So sodium oxide, sodium chloride, sodium sulfate. So the name of the positive ion is the same as its metal. In here we have only small, let's say, detail to explain, which is some positive ions have more than one oxidation number. So the name stays the name, but here we need to use the Roman numbers. Here the Roman numbers should be added to the confusing positive ions or confusing cations. If you want to understand more, my friends, you have to go back to my course, Mr. Odate chemistry course. There is a class into which I have explained positive ions and negative ions, and we said that some ions have only one possibility. For example, sodium always +1, calcium always +2. But some ions, positive ions, sometimes get +2, for example, sometimes get +3. This depends on the nature, the parameters, the circumstances of the reaction. So for example, copper has 2 oxidation numbers. Sometimes it loses 1 electron, so that becomes +1. Sometimes loses 2 electrons to become +2. So in here we have iron, we have copper, and we have chromium, and sometimes we have this lead, +2 and +4. So how can we name them? Here we add to the name the oxidation number in the Greek letters. For example, this is iron. This is a free element. And here oxidation number, OR, equals 0. Because this is a free element. In here we have iron. Look, we have iron 3 chloride. How do I know iron 3? Because this is -1 and it takes a 3, and here we have 1, so that's FeCl3 iron 3. So we have Fe2O3. This is called iron 3 oxide. How do I know? Because there is FeO. Here FeO is iron oxide. Iron 2 oxide. So here there is a mistake. We should write this, the name, correct name here is iron 3 oxide. And here, for example, we have FeCl2. This is iron 2 oxide. So we need to use the Roman numbers. Roman numbers 1 is like this, 2 is like this, 3, 4, and 5 like number V, 6, 7, 8. This is 9. 9 means 10 minus 1. And this is here 10. And here we have 4, for example. Look, 4 is 5 minus 1. This is how to name the positive ions. Now let's go to the negative ions. To know how to name the negative ions, we have to understand that we have two major cases. Naming positive ions finished. And now we have to talk about naming the negative ions. Naming the negative ions here, we have also two major cases. And within each case, there are two minor cases. Let's start with the first major case is negative ion. How to name a negative ion which is bonded with hydrogen, H+. So a negative ion with H+. In here, my friends, all chemical compounds, all negative ions that are bonded with here, H+, plus any anion means negative ion equals acid. So what is the definition of an acid? An acid, my friends, is a chemical compound that is made up of hydrogen and a negative ion or an anion, and it can release H+. So all chemical compounds here are called acid. So how to name these acids? Naming these acids is not difficult, but here we have to understand that we have two types of anions or negative ions. The first one is the monoatomic and the polyatomic. Each one has its own nomenclature. So my friends, here, how to name a negative ion which is monoatomic that is bonded with hydrogen. The way here is very easy. We add hydro. Here we add hydro, then the name of the halogen, for example here halogen, then ic acid to the name. For example, we have HF. HF is hydrofluoric acid. Hydrofluoric acid. Hydrofluoric acid. We have H here, hydro. Chlor, this is a chlor, and we add ic acid because now they become acid. So hydrochloric acid. Here we have H, hydro, Br, brom, and ic acid because both of them are an acid. So we have hydrobromic acid. For oxygen, which is oxide here -2 and sulfide here -2, we have water, of course, and hydro because hydrogen, sulfur, we have a sulfur, and ic acid because both of them now here are acid. So this is hydrosulfuric acid. Now, the second minor case is when the negative ion is polyatomic and it's bonded with hydrogen. It is bonded with hydrogen. Also, we have acids, but here the name is ic acid. We don't need the prefix hydro. Here, we don't need hydro. So we have nitre, here, the name of the nitric acid. This is nitric acid, and this is sulfuric acid, and we have phosphoric acid, and we have carbonic acid. As we see here, my friends, those are the cases when the negative ions or anions are bonded with the hydrogen. Now, what if the negative anions or anions are bonded with any other positive ion? Of course, not hydrogen. In here again, my friends, we have the same two minor cases, the monoatomic and polyatomic. The monoatomic here, we add ide for halogens. So here we have sodium, as we said before, for the positive ions, look, positive ions, +1, +2 ions, iron 3, this is copper 2, this is calcium. The name of the element is the same as the name of its positive ion, but negative ions, we need to add suffixes and prefixes here. The suffix is "ide", so we have sodium fluoride. What do you mean by "ide"? "Ide" here means that fluor is a negative ion that is attached to a positive ion which is not hydrogen. What do we mean by bromide? Bromide here means that brom is a negative ion which is attached or chemically bonded to a positive ion, and this positive ion is not hydrogen, because if it was hydrogen it would be ic acid, hydrochloric acid, hydrobromic acid. Here we have chloride, bromide, iodide. Calcium chloride, we have copper iodide. As we see here, my friends, we have oxide, oxygen, oxide like aluminum oxide. We have iron oxide. We have sodium sulfide. We have copper sulfide. Again, means the sulfur is a negative ion that is attached to a positive ion, and this positive ion is not hydrogen. For the polyatomic anions, my friends, we only need to add what? We only need to add the positive ion name, then 8 for the negative ion. Here we have magnesium, we have aluminum, we have ammonium, we have iron 3, and here we have nitrate, sulfate, phosphate, carbonate. As you see here, my friends, we don't have carbonic acid. Why? Because here this NO3 was attached to hydrogen, which makes it acid. Here sulfate is attached to hydrogen, which makes it sulfuric acid. In here, my friends, they are not attached to hydrogen, so we add 8: sulfate, phosphate, iron, carbonate, as we see here, my friends. So as you can understand, my friends, the nomenclature now is a little bit easier. Now let's go and let's talk about the nomenclature here. As you see here, we have sulf 8. Why is it 8? Because this negative anion, polyatomic anion, is attached to a positive ion which is not hydrogen. So the name of this chemical compound is zinc sulfate. Zinc sulfate. Now let's go to the next question, my friends. Next question stipulates, completes here hydrogen chloride. Here, as you see, hydrogen chloride and magnesium chloride have different types of bonding and have different structure. As you see here, we have hydrogen chloride and magnesium chloride. They are different. Complete the dot and cross diagram for the outer shells. As you know, hydrogen has only one atom, so one electron, so it has only one shell. And the name, can you remind us the name of the shell? Yes, the name of the shell was K, and K can take 2 electrons, but hydrogen has only one electron. So the cross here, the cross is for hydrogen electrons, hydrogen electrons. And the circles here, as you see, my friends, the circles are for, or the dots here, circles or dots are for the chloride. Chloride 17, we have 2 here, 8, 7, so the last shell contains 7 electrons. Here, as you see, we have 2, 4, 6, and this is the 7th one. So after chloride is attached to hydrogen, they make hydrochloric acid, and the octet rule is achieved. Now the diagram here shows the electronic configuration of magnesium atom and chlorine atom. For the magnesium, as we all know, magnesium has a 12 here. Magnesium has 12 electron. So we have here 2 in shell K, 2 in shell L we have 8, we still have 2 electrons here, the last shell. Here, chlorine 17, we have in K 2 electrons, in L we have 8 electrons, and we still have here in in M we have 7 electrons. As you see, 2, 1, 2, 4, 6, and this is the 7th one. And here, draw the electronic configuration of magnesium ion and the chloride ion. As you see, my friends, as you see here, my friends, the magnesium has 2 electrons in the last shell, so it will have 2 options: to lose 2 electrons to become Mg plus 2, so that the last shell will become shell L and has 8 electrons, or to gain 6 electrons to become magnesium minus 6, which is impossible. So magnesium prefers to lose 2 electrons to become, and as we all know, my friends, magnesium prefers to lose 2 electrons to become Mg plus 2, because gaining 6 electrons is something impossible. For chlorine also, chlorine has 2 options: either to gain 1 electron here to become 8 electrons and chloride become minus 1 because it gained 1 electron, so it becomes charge minus 1, or to lose 7 electrons to become plus 7, and this is impossible. So here we need, here I need you to understand something here. For electronic configuration of magnesium and the chloride, when magnesium will react with the chloride, magnesium will need 2 atoms of chloride. Why? Because magnesium has 2 electrons. For chlorides, each chloride has 7 electrons in their last shell. Here, 7. Each one has 7 and needs 1 electron. So magnesium will give 1 electron to 1 chloride atom and 1 electron to another chloride atom, so that each chloride can take 1 electron. So for 1 magnesium atom, I need 2 chloride atoms to become chloride. And as we see here, my friends, after this magnesium loses 2 electrons, the last shell becomes here, this shell becomes what? Becomes empty. The last shell will become the second shell, Kl, as you see here. And of course, for chloride, the electrons that left will come to this shell, so we have extra electron for chlorine. And now, my friends, let's answer the last question here. Explain why magnesium chloride has much higher melting point than hydrogen chloride. Here refer to the structure and bonding. I left the answer here for you theoretically, but I will answer it practically in 1 minute. So this MgCl2, the number 2 should be a small number, but you know, I copied and pasted so that the number cannot be this way. So I'm correcting it for you. And now the answer is hydrogen chloride, as we all know, has a simple molecular structure with weak intermolecular forces between molecules. On the other hand, magnesium chloride has giant ionic structure. Here, the structure of hydrogen chloride is simple molecular structure, while the structure of magnesium chloride is giant ionic lattice with a strong electrostatic attraction. Here, weak intermolecular forces between molecules. So, my friends, that's why the magnesium chloride has higher melting point than the hydrogen chloride. Till here, my friends, the answers are finished. I'm sorry for making this video a little bit long, but we had to explain a lot of important things. In the next class, my friends, we are going to go through question number 10. Till that time, my friends, I wish you all the best and goodbye.